Hi, I'm Rachel. My dissertation is Visualising Societal Resilience. This is the research team. Beatrix and Andrew were my supervisors, and this project is nestled within a larger project that's been run by Anne and Peter from Koi2. Koi2 is a think tank at the University of Auckland, and the other organisation involved in the wider project is INGSA, which is the International Network for Government Science Advice. There's a lot of words on this background page and not a lot of time to get through it. So, in a nutshell, this project sits within the Societal Resilience Project, and that project is aimed at identifying the factors that affect societal resilience, understanding how they interact within a complex network, and presenting that material to an audience of policymakers. This is the timeline for the Societal Resilience Project. Firstly, the factors that affect societal resilience needed to be identified, and this was done with a group of experts from INGSA in London at a workshop. They identified 36 factors that represented 1,300 asymmetrical relationships. Then the idea was that these get quantified. Koi2 realised that 1,300 relationships, this is too much to cover with a survey. So they identified about a third of those relationships where they could say, well, it's obvious that there's little to no relationship here between these two factors, and they were excluded from the survey. So 2/3 of those relationships went out in a survey that was online, and each person who contributed answered 50 questions where they had to rate these relationships. There were 200 respondents. This is when this project here starts. So the idea was that we would visualize that data for policymakers, and then eventually a tool gets rolled out. So in terms of this project, to visualize the data, if you look at networks, any network package and say R or Python, you're going to find some sort of demonstration that presents you with images that look like this. And I experimented with these, and this is one of my experimentations. So they look cool, right? They do look cool, and you can move them around and change the sizes of things, but they're not very easy to understand. So that was really the challenge. So we have this problem that we want to create this tool that visualizes the societal resilience survey data for an audience of policymakers, but it needs to be intuitive, it needs to be informative, and it needs to be really clear and useful to the policymaker in their work. That process also needed to be extendable to other complex networks for policy relevant topics. So in terms of the methods that I went about, probably the most interesting aspect was the clustering. We wanted to reduce complexity a bit, try to simplify what we were presenting. So if we could maybe aggregate up some of these factors into a group, then the presentation might be a bit more clear. So we clustered using hierarchical agglomerative clustering, and the idea was to find groupings of factors that affect and are affected by other factors in a similar way. Because of that sort of specification, we needed to do a sort of homespun distance measure, which Beatrix Jones came up with, and I've called it bidirectional distance here, just for the sake of giving it a name. We have this result on the right, which is the dendrogram of the factor clustering, and we started out with 6 clusters, and eventually, because it needed to be understandable and intuitive, moved to 14. The problem was, though, that as Beatrix sort of raised this issue, she said, well, if you've removed a third of the questions from the data set, is your clustering just going to be reflecting that? And it was. So on the left, you can see correlations based on responses that we got, and on the right, you can see correlations based simply on whether or not a question was asked. So no values in there. That's just binary. data, building up that correlation matrix. It's all ordered by the clustering. So those squares you see there are the sort of clusters where you see higher correlation, and it's pretty much the same. So that was a bit of an uh-oh moment. However, we still found this process useful. So if we have just a quick look at the tool I actually built in the end, here it is here. A couple of different types of visualizations we used, but I'm just going to look at the networks because I showed you a network diagram before, and here you can see this is a bit easier to understand. So I've taken a hierarchical approach, which also means that you end up having some nodes repeated in this diagram because I'm only um, there's no two-way arrows in any visualization I built. The idea is that you can clearly see the direct effects on any one factor that you choose, and then you can also see the indirect effects, but you're only seeing indirect effects back one level. You can choose which factor of interest you're interested in. By default, we see societal resilience here, but we might be interested in arrows going the other way and seeing how compliance with civic values affects other factors. What is also good to note here is that we've actually only presented a few relationships here, the ones that are the most meaningful according to some sort of thresholds that we came up with. This is a category network, which is aggregating up the factors to those clusters that we identified earlier and representing those instead of the factors themselves. Okay, so to test the tool in Wellington, we had sessions with policymakers, ended up getting 13 people. We observed them using the tool and then we interviewed them. So the result was they really liked the tool. They found it relevant to their work. They really liked the network diagrams. The interactive element, which could be a bit gimmicky, was very engaging for them. And they liked seeing the indirect effects. They wanted to know more about these experts that answered the survey. So we really need to build up trust in that data because it is an educated and skeptical audience. Project highlights were the Beatrix's distance measure and finding this imposed structure that was imposed top down but discovered by the sort of bottom up method of clustering. But we would not have known this without doing that clustering, and the clusters that we got in the end were actually really intuitive and made sense. In terms of a significant discovery, policymakers have a lot of reports they need to read. The benefit of a network diagram is that it's a really good visual aid for those early stages of policy making. So where should I be looking before I sort of delve into all these reports? It's not a replacement for the reports, but it helps give policymakers some direction. In terms of the future, the next policy topic that will be explored using a process like this is youth mental health. The main contribution of this project is that it validates that a tool visualizing complex networks for policy topics can be acceptable and useful to policymakers in the work that they do. So thank you for listening. I hope you have a nice day.